We are back with our Friday lesson here. Going to wrap things up this week. I want to go over the section review questions with you from yesterday and also go over your warm-up answer with you in this video. I made a second video with the lab experiment on it because I kind of got a little bit lengthy there. So we want to let you watch this one first. So you go over the questions to your the answers to the review questions from yesterday. Then we'll go over your one question and get you ready for your lab experiment. So without further ado, let's take a look at our there we go. That better? I think that works better. Okay. So the section review questions. First one says a jet plane is flying east at 800 kilometers per hour. Another one is traveling north at 880 kilometers per hour. They're both 880 kilometers per hour. One's going east, one's going north. Do they have the same velocities? Do they have the same speeds? For that one, speed, yes. They are definitely the same. The speed of both of them is 880 kilometers. The velocities is different because velocity is speed plus direction. Question number 2 says a swimmer speeds up from 1.1 meters to 1.3 meters per second during the last 20 seconds of the workout. What is the acceleration during this time interval? So again, we want to write down our info. Velocity initial was 1.1 meters per second. The final velocity would be 1.3 meters per second. The time interval will be 20 seconds. Our equation, we're using the acceleration equation, VF minus VI over T. To solve that, we take 1.3 minus 1.1, which will give us 0.2 meters per second divided by 20 seconds. Our answer will be 0.01 meters per second squared. And I keep drawing a box on that because, again, we don't have to memorize units. We're just going to use the unit that we have already in place there. Your warm-up question today. This is going to simulate your lab. For your lab, which we're going to do here in a few minutes, we're going to take a volleyball and a basketball, the top of a ramp. We're going to roll it down a ramp and then let it roll across the floor. We're going to determine its velocity at point B, the acceleration from A to B, the velocity at point C, and the acceleration from B to C. So that's why I gave you this one question today. Whether it's a car, a volleyball, a basketball, anything rolling down a ramp and then rolling across the floor would be the same thing. So the velocity at point A, it's stopped. The car's velocity is going to be 0. It's not moving at all. It rolls down this 2-meter hill in a time of 2 seconds. So the first thing we're going to find is the velocity at point B. Velocity, our equation, is distance divided by time. Our distance is 2 meters. Our time is 2 seconds. So take 2 meters divided by 2 seconds. The velocity at point B would be 1 meter per second. We then want to find the acceleration from point A to point B. So the equation for that is final velocity minus initial velocity divided by the time. Our final velocity, our velocity at point B, we just calculated that. It was 1 meter per second. Our initial velocity up here at point A, we said is 0. It's not moving. So 1 minus 0 is 1. Divided by 2 would be 0.5 meters per second squared. Now we want to go from point B to point C. We want to find first the velocity at point C. So the velocity at point C, again, is distance divided by time, which would be 2 meters divided by 4 seconds. So our velocity at point C would be 0.5 meters per second. To find the acceleration from B to C, we need to take the final velocity, the velocity at point C, which we just calculated to be 0.5 meters per second, minus the initial velocity, that's our velocity at point B. Now remember, the velocity at point B was the final velocity for this acceleration equation, for the ramp equation, but it's going to be the initial velocity for the roll equation. It can be both. So our final velocity, the velocity at point C was 0.5. The initial velocity, right, the velocity at point B, we calculate here to be 1 meter per second. Our time was 4 seconds. Something different that we have not seen yet is the velocity at C is less than the velocity at B. So if you have 0.5 minus 1, you're going to get a negative number. We haven't had a negative number yet, and that's perfectly fine. You can have a negative number. That just means you're decelerating or slowing down. A negative acceleration is fine. So we have negative 0.5 divided by 4 seconds, acceleration was negative 0.125 meters per second squared. That means it was slowing down during that time period. While you are calculating your lab tonight, if you want to go back and rewatch this video on how we calculate, it's going to be the same thing. Point A, point B, point C. That's why I chose this as the warm-up question for today, because it's going to be the exact same way you calculate the ramp and roll of both your basketball and your volleyball. So again, after you're done with your lab, if you have questions, please let me know. I'll be happy to help out. We will get those turned in. How about I give you until Monday night to turn those in? That way, if you have questions, we can go over them on Monday if we need to. So have a fantastic evening. Have a great weekend, and I will see you guys on Monday.